Guys, I'm back. I'm Chet Udell, and we just went over getting started with putting the hardware together. So if you haven't seen that tutorial, go ahead and watch that one now. Next, let's go ahead and talk about the Digital Data Workstation and reading all of your sensor data into this application. So this app, DDW, or Digital Data Workstation right here, is a play on the Digital Audio Workstation, or DAW, or DAW. And those are programs like GarageBand, Pro Tools, Logic, except that instead of working with tracks of audio streams, you're going to be working with creating and processing tracks of wireless data streams from your emotes and then sending them to control whatever audio or visual or video game hardware or software imaginable. So, very exciting. The first thing that you need to make sure is that go ahead and plug in your fuse. You need to have your fuse plugged in before you start up the eMotion Digital Data Workstation. Once you have that going, go ahead and double click on that application and let's get rocking and rolling. Here we go. Let's go ahead and I think it opened up in a different window, so let me go back. Let me go back here and try that again. So let's get rocking and rolling. Take two. So just double clicked on that application and you're going to see a window. It's going to look a lot like, suspiciously, like MaxMSP. And that is because this was created in MaxMSP, but it is a standalone application. So you don't actually want to open this with MaxMSP, and you don't need the MaxMSP program in order for this to work. If you don't know what MaxMSP is, that is perfectly fine. Alright, so the very first thing we want to pay attention to is this green box here. And if you accidentally close the window, that's fine. You'd be like, oh no, I can't find it. To get the green box back, go ahead and click the green button, and that will bring up the eMotion fuse again. Now, very first thing, second most important is after you've plugged in your hardware, you've turned on the app, you want to make sure you have the proper USB serial device selected, because this is where we get the data in from the fuse. And the device you want to look for is something that looks like USB serial /AM. It's apparently a morning person. And then whatever else is here. So USB serial AM blah blah blah. So I just selected that. Now I'm going to turn this thing on, and I want you to notice that I am on channel 15 right now. And this is arbitrary, except that you should understand the theory behind it. So every eMotion fuse, which is this thing attached to my computer, comes on its own channel. Like it has, every fuse has its own unique channel. And the reason for that is because maybe you want several of these devices in the same environment. And so you can actually have several fuses all hooked up to their own computers or even the same computer, though I haven't tested several fuses on one single computer. So one fuse, one computer, try to stick to that. In any case, make sure that all of them, if they're in the same environment or same range, that they are on different channels. And then you could have all of your emotes paired to their own unique base station. And this is not unlike video game systems with wireless controllers. This is why people can use their Xboxes and Wiis all together because of these special, channel and handshaking algorithms. So the next thing is now that I've turned on my fuse, I've selected my device, turned on my fuse. The next thing is to check out this window, and I want you to see it says stop. Please turn on all emotes and eMotion modules before starting. Now what this means is that when you click this stop sign, and don't do it yet, what it's going to do is it's going to look for all of the emotes on the network, and we're just about to turn ours on right now. And it's also going to look for all the modules that you had that you were using in your previous session. So you want to make sure you have all of those started up. And we're going to do that right now. So now we have this started. Make sure this stays on 40 Hertz. Don't worry about that. And now this is the emote list. If you accidentally close this window, oh no, go ahead and click on that button there and it's going to open up that emote list again. Now this is important because when you turn on your emotes on the network, they will pop up in that window. So let's do that right now. You have your emote. This is the button on the very bottom. You should press that button now to turn it on, and you'll know all is well when you see that green light. And I want you to check out what happened here. We have this mod twist 0. So now what you can do is double click that. I want you to see how everything's kind of percolating away. Now if you want to learn all the special things about the twist, you can go ahead and click on that help browser. There will be a whole video on what the twist does. But for now, just know you have to calibrate this thing for it to work properly. So I'm going to go ahead and click this button called Calibrate, and you'll see the little percentage doing its thing, and I'll explain what that is in the twist tutorial. And I don't even need to watch that calibrate now. The next thing is go ahead and grab any other sensor that you intend to use. This is the accelerate. I'll go ahead and turn that one on. And then I'm going to switch this window real fast so you can watch the accelerate pop up. It will only take like maybe 5 seconds. So now go ahead and double click on this accelerate. And you can learn all about the accelerate as well in the next tutorial for explaining the emotes, but just know that you have to calibrate everything. So I'm just going to go ahead and calibrate. Click the little button that says calibrate, and bam, we're in business. All right, so now that I've turned on all of my emotes, now I want to turn on my modules. What does that mean? Well, any application that is going to speak with the Digital Data Workstation, and this could be Pro Tools, it could be C Sound, Maximus P, Pure Data, but you have various things waiting for emotion data, and I'll go ahead and explain that in just a moment. But for now I have a variety of different ones we might be able to use. So I'm just going to go ahead and turn on this eMotion 3D pan. I'm just going to open up that application here. This is another application that just pans your pans a sound around in 3-dimensional space or 2-dimensional space. And if you want to learn more about this, click its help browser. I'll go back to the workstation. Now that I have everything started up, now I can click this red button off to the side. So click. And then it's going to ask you to wait for a little while, and that's cool. It might crash what it just did right here the first time. That's perfectly normal. This is beta software. So what you can do is just reopen. And now that you are reopening this, you may need to turn your emotes off. For me, as long as you just turn the Fuse software on as quickly as possible, both of these things should just pop up here. And you'll just calibrate all that stuff again. I know it's tedious. Someday I'll be able to afford very expensive programmers, and we won't have to deal with minor inconveniences like that. But the other application, you should know, didn't crash with the other, because they're all their own things. Now what I'm going to do is go ahead and click on this, and I want you to see something. So bam, data track has started. It's going to tell you to wait, so go ahead and wait until it says ready. Ready. Perfect. All right. And so this is pretty cool. For the input, you can select between your 2 different emotes. And in the second menu, it's going to give you a variety of different sensor ports based on which emote you want to listen to. Now, if you have several different emotes, then you'll have emotes with different numbers. So you'll have like a twist 9 or an accelerate 7. And those are your different emotes if you use several of them. But for now I only have 2. So let's go ahead and go to my twist, which is here. And let's go ahead and mess around with the gyroscope. And notice how if I roll left and right, my gyro shows acceleration on the left and right axis. So I'm going to go ahead and use that. So I'm going to go to twist 0. Going to make sure I have gyro X, and I want you to take a look at the processing window. We should have something along the lines of like a 0 and 1 to a 0 to 127, So I want you to go ahead and move your twist, back and forth. I want you to pay attention to the data range here as you're doing that. Notice how my numbers are percolating between -20 and -20, right? And basically that's in degrees per second. That's the units for the gyroscope. So I'll just do -20 to +20. This is where I will rescale my data. And maybe I want to turn this into a 0 to 120. Well, we'll get to that in just a moment. So now that I've turned this into a -20, +20, that's updated my waveform to move with my data. So you see how my waveform is reflecting what that data looks like on that axis. So it's pretty sweet. Now let's say I want to rescale this to like MIDI. So 0 to 127, I'll go ahead and click this rescale. And I want you to look at the waveform here. The waveform will eventually update. And you'll see that when I hold my twist sideways, I'm sitting roughly at halfway between 0 and 127, which is 64. And then as I move up and down, I get corresponding peaks and troughs in that data. Pretty cool. Maybe I don't want 0 to 127. Maybe I want 0 point to 1 point, right? Or 0 to 100. And so the data will eventually update when you change that. And we'll go over some of these other things. The next thing in the processing window, so now that I've selected a data input, the next step, I know I kind of skipped ahead, was right to processing. And I sort of jumped ahead to this rescale stuff. Even before you get to rescale, we have filter strength, and this is pretty cool. The filter strength is going to put resistance or smoothness on the data, whether it's going up or down. And so if I turn all of my smoothing off, I want you to notice that my data can be pretty noisy as I'm, just really slight variations in this. And this could be somewhat annoying if you're controlling a parameter that shouldn't be percolating around. So how do we mess with that smoothness? Well, rising, the more you have the rising, the harder it is to get your data up to the top. But the easier it is to move your data to the bottom here. So do you see how when I move the data all the way to the bottom, see how it takes a while to sort of percolate up here? Like it just takes a while. See that? Really slowly. But if I put a lot of resistance on falling and nothing on rising, then I have sort of an opposite effect, right? So it's easy to go up, but really hard to go down. And so if I just kind of put this here, adjust my rising and falling, I'll actually get some pretty darn smooth data. And you just need to kind of tweak with this. You'll figure out what is best for your particular purposes. Another thing here is the label. Oftentimes you might want to call your data something. In this case, I might call it, I don't know, distortion. That way I can look for a data stream on my output called distortion with the name of that data. So we'll get into that in just a moment. Threshold detect is pretty cool. So let's say I want to trigger an event only when I move really hard over to my right hand side. Bam, like that. So I can do threshold detect, and I'm going to detect a threshold. How high? Let's say I'm going to detect it at about 10. So when I get to 10 degrees, roll at 10 degrees per second to the right, I'm going to get a 1. And I want you to notice here that when I turn my twist fast enough to the right, bam, 1, bam, trigger something. Okay? Now, this could be really useful. Let me change this to something different. I'm going to change now to the accelerometer, Excel X, and I'm going to make sure that I sort of adjust my rescale to data that I expect. I'm going to turn the threshold off for now. So right now, I should see. Rescale. Rescale. Okay. So right now, if I tilt my twist all the way to the right, I get +1. If I twist it all the way to the left, I get -1. So that's pretty sweet. Let me go ahead and save the rest of this for the twist tutorial, shall we? You just want to learn how to learn the Digital Data Workstation. So let's just keep rolling forward on that. So threshold detection, let's say 0.5. Let's say when rising and falling is really nice to be able to set. So 0.5 is going to trigger when I tilt right at about this here. And the reason why I have rising and falling different is maybe I only want to trigger something at 0.8 is when I want to go to 1. So I need to tilt all the way over here. But it's going to stay at 1 until I go all the way back past 0.5. Or even better, maybe I want to keep it at 1 until I go all the way back to -0.5, right? So that way I can have many different states. So turn on when I lean here, and then when I go all the way back to 0.5, do you see how I turned off? So 1, and then lean all the way back, and now 0. And this 1 and 0 thing is going on right here. So one more time. 1, then lean all the way back. Bam, 0. So that's why I have the different rising and falling thresholds. Okay, so threshold detection, that's pretty good. Spring mass, that's kind of cool. So here is a physical model, and you can use any of these spring masses. For example, take a look at the bobbing up and down, and that is emulating the small spring here. If I want a wider spring, I just click on the heavier mass at the end. And you see how my springiness is, well, amplified, right? Whereas if I click on the small one, I have less springiness. Right? Okay, so that's pretty cool. That's all really fun to play with. Yeah, and so, all right, we have input, we have processing. Now, whereas the magic happens is the output. And because I have an application right here, 3D Pan, any applications that you have open are going to populate in your output window. You also have 2 default as well, default outputs. OpenSoundControl, which will let you communicate to things like Max MSP, Super Collider, C-Sound, virtually anything. And then MIDI out as well is really important because a lot of programs like Ableton Live and all kinds of other programs, take MIDI data as well, just about any of them. This could also be MIDI out would be really useful to control hardware as well. So if you have a synthesizer or a MIDI to CV converter for analog synthesizers, this is really fun to play with. So OpenSoundControl out, let's go ahead and just do that. And if we're in OpenSoundControl out, you can click on OSC out and you can set your IP, and your port is, if you want to use local stuff, you can do 127.0.0.1. You can just keep it there and that will communicate on your own computer. If you have a remote or networked computer, you can simply put in the IP address of that network computer and a port, and then you will get data through network onto that computer. So that's pretty awesome. And you can assign a different OpenSoundControl IP address and port for each track. So you can send your data to many, many, many different places. So let's do 9436 with the IP of my local host. And let's go ahead and get data to this. So what I'm going to do now is I'm just going to open up I'm just going to open up a program that will take OpenSoundControl data. And the fastest one that I know how to use is Max MSP, but you can do this with Pure Data, Super Collider, anything. So now we're starting up Max MSP. I'm going to create a new window here. And now I'm just going to create a UDP receive with the port 9 9436. And then I'm just going to let it print out to this window here. So UDP receive 9436. Binding to port 9436. OpenSoundControl out. 6. And we should theoretically start seeing data get printed out in the max window. Let's see. Interesting. Hang on a minute. Yeah. So here's another really important thing. So in order for OpenSoundControl to work, you also, in your processing window, you need to give it what some people might call an address, other people might call it a destination, a parameter name. There's all kinds of things people are calling this, but basically you just give it a /, and then you can just type in, all right? And this can be, really the name is arbitrary, but when you switch to your other program, UDP receive with the same port, you will see that data percolating along. And basically it will respond. I get a +1 when I lean here, -1 when I lean here. And that all is because of the input that I selected. If I wanted to select a different input, that would, and send it to that same place, I just have to change the input or change the processing. For example, let me reinforce this. I'll change this to MIDI data, 127, 0 to 127. I'll turn the rescale on. I'll go back to Maximus P. And now as I lean back and forth here, I should be dialing numbers between 0 and 127, roughly. And you'll just adjust your ranges as necessary. Cool. And that's basically it in a nutshell. If you want to create a new data track, that's as simple as creating a new track here. So click the blue button, bam. And now all of your settings for track 1 should be saved, right? For track 2, you just select something else. So I'm going to select the accelerate, so my other emote, I'm going to select Excel Y. And I'm going to make sure that, so this is my accelerate, and it's different because of this plugin port, so I'm just leaning this up and down. Bam. And I'm going to go ahead and select a different destination. I'm going to do pan input 1, and I'm going to do the y-axis, which is for close and far away. So here. And I'm going to create a third data track, and I'm going to do the accelerate as well. Accelerate 0. And I'm going to do Excel X. And I'm going to send this out to input 1x. So accelerate X is going to input 1x. Accelerate Y, input 1y. And let's go ahead and take a look at my 3D pan. And I want you to notice that, get to a place where you can see both of these gizmos. When I lean right, notice how I'm panning my source to the opposite side of the room. Now this isn't ideal, right? Now when I pan up, that's following me around. Up and down is fine, but left and right is backwards. So let's fix that in our processing. So that's the x-axis that's giving me the trouble. And what I'm going to do is I'm just going to invert this. So I know my data is between -1 and +1, and I know that because as I lean to the right, I get, pretty approaching -1. If I lean to the left, I get +1. And I'm going to change this just to be backwards. I'm going to change -1 to 1, and change 1 to -1. And now I should get something that looks like this on my 3D pan program. I'm going to change it so you can see me. Left, right, up, down. And as you can see, it's really sensitive. All right. And so that's the Digital Data Workstation in a nutshell. I demonstrated getting data to other applications and also getting data to to MaxMSP or any other program, theoretically using your OpenSoundControl outputs. MIDI output is the very same thing. You'll just select MIDI out, and then you'll click this blue tab. You'll select your from eMotion Digital Data Workstation, and then you'll set your controller and channel number, and then here's where you can select your control or note out. So that is really, really useful. And then, is there anything else? No, I think that's it. So that's the Digital Data Workstation. As I say, that was the short version. All right. Thank you for bearing with me. Have a good day.